What up, beautiful people? This is your boy D Blancas coming right back at you with some geometry. Today we're looking at lesson 17, characterize points on a perpendicular bisector. So this lesson is going to be fairly short, somewhat easy, but extremely important. All right? So we're going to start with this opening exercise. If you read that paragraph, they just want us to construct a perpendicular bisector. So right where the line starts, so let me zoom in so you can see this beautiful image. Right where the line starts and right where it ends, I'm going to put 2 points, right? And we've done perpendicular bisectors before, right? So when we do this, just past the halfway line, doesn't matter where, right? Doesn't matter where, as long as it's past halfway, you set it up and you draw your circle. Flip it, don't change the distance, but now you flip it and you do the exact same thing, just like so. Right, so we've done this before, plenty of times. And where they intersect, right here and right here, we're gonna connect, and that's typically our perpendicular bisector, just like so. All right, it's just a little bit off, but that's fine. But that's how you construct a perpendicular bisector. Cool. So now there's some definitions here. Let's go over it. Two lines are perpendicular if they intersect. All right, so if they intersect and if any of the angles formed by the intersection of the lines is a 90-degree angle or a right angle. So we know right angles are 90 degrees. Right? So two segments are perpendicular if the lines containing them are perpendicular. So that one's just straightforward, nothing too fancy. But some things that you need to know, perpendicular. All right, cool. So we're done with that opening exercise. Example number 1. This is what example number 1 talks about. So there's a line of reflection. This image is reflected. And we know that in order to reflect an image, we use perpendicular bisectors. We use that a lot. And we're going to need it to find the line of reflection, where it's at. So that's what we need to do. They're asking if we can find the line of reflection without using perpendicular bisectors. So what do you think? If you said yes, that we can find the line of reflection without perpendicular bisectors, you, my friend, are wrong. But if you said no, we need perpendicular bisectors because it'll be crazy to not use them, then you, my friend, are correct. Right? So that's all they want us to really think about. And if you forgot how to do this, let me do it very quickly. So we have a point right here, and this is the corresponding point. And all we do is just like the opening exercise, you line this up. You can line this up with just past the halfway point, which is right there. Draw your circle, or half of it, and flip it around and do the same thing, just like so. All right, and all we did was use these 2 points. If you want to draw the line, connect them, you can, if that helps you. But notice now here and here, so if we connect that, that is our line of reflection. There's a line of reflection right there. All right, so we needed to use the perpendicular bisector. We needed to use perpendicular lines in order to create the line of reflection. So moving on to page 94. So flip it around. All right. Now here's a discussion. So they give you this image right here. So this is example number 2. They give you this image. They're using the exact same triangles that we used, these points. They want to know, does GP, so if I do GP, does that equal HP? Are they the same distance? They just want to know, again, if this line is the same distance as this line over here. Take a few moments, see if we can figure it out. Welcome back, class. I hope you took a few moments to try to figure it out. All right, I'm gonna show you how to do this. So I'm gonna grab P right here, put it in the center, and I'm gonna line it up with H. All right, and then using H, I'm gonna draw a circle. You see how it goes through H? Awesome. So I'm gonna keep doing that. I'm gonna draw the circle. Oh, just like so. And you can complete the circle if you want, but I want you to notice something. P was my center. This was my center. So that means P to H was a radius of my circle. All right? But look at this circle also crossed G over here. So that means P to G is also a radius of my circle. So that means that these two have to be congruent because all radii of the same circle are congruent. So I'm just going to write that in words over here. GP is congruent to HP because all radii are congruent from the same circle. From the same, hopefully you're writing this out too, circle. All right, there you go. You youngsters probably use the letter Z, so I'm going to change that to Z, because there you go. Mr. Hip. That's me. I'm Mr. Hip. I'm hip. I'm down with all you kids. But there you go. All right. And it doesn't matter what P is. If I were to draw here and connect this down this way and connect over here, it's still going to be the exact same distance. Or if P was over here, connect my G there, connect my H there, same distance. And you can test that by drawing the circle like we did. But you're going to find out that they're the same radii of the same circle, so same distance. So that's another thing that's very interesting about that. All right, flip. Now we're going to example number 3. All right, this has to do with the center of rotation. So what this is saying is that we need to find the center of rotation for this transformation below. All right. Oh, you can't see that. Oh, no, where am I? Right there. So this was transformed. This was rotated, right? And we need to find the transformation below. And so how are perpendicular bisectors a major point or a major part of finding the center of rotation? Why are they essential? So what we need to do is this. We need to create a perpendicular bisector from this line right here, all right, and from this line over here. So 2 different perpendicular bisectors, and that's going to give us a center of rotation. So we've done this before in previous lessons. So I'm just going to draw that line. Here are my points. Here is this point. And then go ahead and construct your perpendicular bisector. About right there. Not bad. Do the same over here. So that'll be about right there. All right. Oh, I need to follow all the way through. So there, and then going this way. So then follow all the way through. So if I connect these two over here, that's a perpendicular bisector for my green line. Now I need to do this pink line over here. So I'm gonna do the corresponding side, which is that one, and I'm gonna find the perpendicular bisector as well. So put your point. Oh, it keeps moving. Just like so. Flip it. Do it again. Just like so. And then connect where they intersect. So over here, right there. So they connect. There you go. If you notice, they intersect at this point. So that's your center of rotation. And we needed to use perpendicular bisectors to find that. And that's all that they're talking about. And then you end up finding out that the distances are the same. AB is congruent to this AB over here. If we do from A to A, it's the same distance from B to B. All right, so it's just a bunch of stuff that you can figure out because of perpendicular bisectors. Cool. We're gonna flip to this next page right here. So now I'm gonna do number 1 with you, but now they wanna know what you got. What type of transformation is this? This is a rotation. It was just rotated. So I'm gonna write rotation. Are perpendicular bisectors used? Yes, they are used. How? To find your center of rotation, to find your point of rotation. All right, and examples of distant preservation, they just want to know which ones are preserved. You can label all of these points, but what you can just say is that this segment and this segment are the exact same distance, the exact same length. That did not change. And if you want to label points, you can. A, B, and this would be A prime, B prime, and all you would say is AB equals A prime, B prime. That's it. That's what you're going to need to do with all of these. What type of transformation is it? Are perpendicular bisectors used? Yes or no, and how? And then provide some examples of distance preservation. Cool? Cool. All right, hopefully this wasn't too bad. Other than that, I hope you have fun. Let me know if you have any questions. So with that, I bid you farewell. So peace out, Girl Scout.